Okay, so now that we've done vertical translations, horizontal translation, and stretching and compressing, we now have these three letters. You have your A, your H, and your K. So our normal function is just f of x. That's where we start everything, just like this. And now we are going to modify it into that. So what do what do each of these things do? So if you have absolute value of A is greater than 1, that's when our A is like 3 and 4 and 5, right? Then we end up getting a vertical stretch. And if A is less than 1, then we get a vertical shrink or compress. And if A is negative, we get it reflects across the x-axis. Remember, our H is our horizontal shift. And it's opposite left and right, remember? And our K is our vertical shift. And that is our up and down. And that's the same. But mainly what we have is our starting point or vertex is going to be H comma K. Starting point or vertex. And our A is what we're going to do. We're going to go up A over 1 for our second point. So these are our steps. We're going to graph that. We're going to graph that. And then we're going to do number 3 is our parent function. Whatever it is, we will put it through there. And you do have to memorize these parent functions. So like this one, we already know our parent function here for an absolute value is that V. The square is going to look like a parabola. The square root looks like that. And we just have to graph them. So how it works is we use our vertex. This is -1, comma 0, because there's nothing being added there. And so that is our first point, -1, comma 0. And then our A is -1. So we're going to do -1 over 1 for our second point. So it's down 1 over 1. And then we place our parent function through it. So this one is a V. So we got to put another dot over there and do that. And that's it. That's how quick they are. So our starting point here, in this case is another vertex, would be opposite for whatever's inside. So that's 2. And then the same for whatever's outside, which is 1. And then our A here is 2. So our A is always that number that's in front of the parenthesis. And so again, we're going to go up 2 over 1 for our next point. So we plot that point 2, 1. And then our next point is up 2 over 1. And then we graph our parent function. Put another dot over there because it's symmetric. And there you go. So you just have those 2 points. It's 2, comma 1. And then it's up 2. So if we go up 2, this point is changing to a 3. And over 1, it's 3. So it's over 1 is 3, up 2 more. Okay, next one. Nothing inside, so that's 0. And 2 is on the outside. And the A in this case, again, is whatever's in front. So it's a negative, and so we have to put some number there. So it's -1. So our next point will be -1 over 1. So we plot 0, 2. And then it's down 1 over 1. Put a dot. And then we graph our radical. So in this case, it's going to go down like that. This is how we graph them. It's nice and quick. Pretty cool, right? All right, next one. It's 1 and then nothing. And our A is -1/2. So again, we're going to go -1/2 over 1. You don't treat it as -1 over 2. It's whatever the number is, that's what we use. So we go 1, 0. And then down 1/2 from there over 1. So right there is our next point. That's supposed to be green. Come on. Green. And then we draw our shape. In this case, it is a parabola, right? This is a parabola with square. So we do that parabola, and it goes wide through a half, and then the other one's half. This is why it's compressed. It looks like that, so it's a wide function. But you get those nice 3 points, one there at the halfway mark, and then that vertex. So this is how we graph it. You're going to be getting those 2 points right there each time using those 3 numbers. So again, it's -1, 0. That's our starting point. And then you use -1, down 1 over 1. Here it was up 2 over 1. Here was a -1 again, so down 1 over 1. And here's the -1/2, so down a half over 1. And that will give us those other 2 points. So let me just show you this with Desmos. So we can pick any vertex. So if we move it there to 2, and then up 5, that's now our vertex. So you can see it's opposite 2, opposite 5, and right now it's 1, so it's up 1 over 1. And then if I change my A, see, it's now up 5 over 1. So it's 1 to the right, and then up 5. And it doesn't matter then what function you have. So if we had the same shift, let's change that from a 5 though. Let's make it like a 6. So that 6 means up 6 over 1. Those 2 points are not changing no matter what function we use. So if we say it's a line, then that's just 2 and 5, see? And then up 6 over 1. It literally becomes that. And if we already did the parabola, if it's an absolute value, it just makes it into a V, same 2 points. If it's a cubic, it looks like a cubic, and so that would be up 6 over 1. And then also down 6, you see, over 1. Right here. So that point right there, it's not going to give it to me. All right, you get the idea. And if we had our monomials, there they are. So that's a square, cube, power 4, power 5, so on and so on. See those 2 points? They're just fixed. It's again because this is our 0 and that's our 1. And so they work with the even root, odd root, see, same 2 points, and even rational. See, it's pretty cool, right? So yeah, there's our points. So let's look at some other problems here. We've got some other little questions that they will ask you. So if you have y equals 2 minus cx squared, all they want you to do now is plug in some random variable. And this is how we get to modify stuff. It's just like me moving that a value. So we plug in a 1, plug in a 2, and we plug in a 3. But that is our a value. Our a here is actually 1, 2, and 3, right? So all that's going to do is cause it to vertically stretch or shrink. This one will be the normal. And then these two will stretch it. So we just need to find our vertex. Our vertex here is 0 and 2. See, there's nothing inside that x squared. There's no parentheses, nothing. So we know there's 0 or 2. This right here is our k. So we go 0, 2. And then our a here is 1. So it's down 1 over 1. And we graph our parabola. See? So on each one, it's going to be 0, 2, 0, 2, every single one of them, because all we're changing is our a. And that just means now it stretches it down 2. And the last one stretches it down 3 over 1. So see how quickly you can graph it. So how that looks in Desmos is, let's write it. It was a vertical shift of 2 and no horizontal shift. And it was a parabola like that. And so our first a was -1. So there it is. It's -1 x squared plus 2. See, it's a positive 2 minus and then 1 x squared. So you can even move that 2 over if you wanted. And there's our first graph. And then now the a was -2. See, so it just goes down 2. And then it was -3. So it's just that number in front of the x squared that's changing. So all it's doing is causing it to go up and down. Okay, so now let's look in reverse. It says find the graph of f of x equals x cubed. So we know it's f of x equals and then a x minus h cubed plus k, is vertically stretched by a factor of 5. That's our a. Shifted to the right 5 units. So it says shifted 5 units to the right. If we go to the right, that's positive, which means ours needs to be opposite. So minus 5. And then 4 units up. So that makes this our h and this our k. So our function would be 5 x plus 5 cubed plus 4. There's our graph. So it's vertically stretched by a factor of 5, shifted 5 units to the right, and 4 units up. So ready? Let's try that. Put everything back to 1, back to 0, and it's a cubic, right? It's a cube. All right, so its first thing said, it's vertically stretched by a factor of 5. So we stretch it by a factor of 5. See, just really stretched it. You can see it stretching by a factor of 5. And then it's shifted 5 units to the right. So we need to move this to the right, which means inside needs to be positive. Negative, I mean. So we need to have a minus 5 here for it to go to the right. Does that match what we have? No, it doesn't. So this needs to change to a minus, see? I even wrote minus too. So it's minus 5. This is why we check stuff. And then it needs to go up 4. See? So there is our graph. It's vertically stretched by a factor of 5. Minus 5 moved it left and right. So this moved it right 5 or opposite. And then up 4. And there is our answer. Matches perfectly. See? Vertically stretched by a factor of 5. 5 units to the right, and 4 units up. There's our vertex of 5, 4, 5, 4, and so on. Thank you.